Okay, so good afternoon to all of you. We are now live with our chemistry session. Okay, so just let me know once if my voice is audible to you. Okay, so the voice is audible. You can see me on the screen. Let us get started with our chemistry session. This is a new series for chemistry previous year question where we will be discussing the previous year chemistry questions, of course. And before I begin with this session, I'd like to inform you that every Tuesday at 1 p.m. we do live sessions for biology, and here we have started the biology previous year questions. And every Wednesday at 1 p.m. we are doing the live sessions for chemistry where we are doing the chemistry previous year questions. Except this, on Saturday, Sundays at 8 p.m. you can see we have started the complete NCERT science series where currently we have started from class 6, so we are doing chapter number 3, okay, and then from class 6th science book, which is your curiosity, and then chapter wise we are continuing. Okay, so let us get started with our this chemistry series. Okay, the previous questions on chemistry, yes, we will do that as well. We have started in a sequential manner. Okay, YIT. The name is very difficult to pronounce. So we have started in a sequential manner and we will go like this itself. Okay, so let us get started. Which of the following gases is most toxic? So we have carbon dioxide, we have carbon monoxide, then we have sulfur dioxide, and we have chlorine. Which is the Yes, very good. Option number 2, Prabhat is here in today's session as well. Very nice. Try to attend these sessions regularly. So it is your carbon monoxide. Why? Because it has the highest affinity with the hemoglobin in our blood, and then it can form the carboxy hemoglobin, which is very dangerous for the body. So the answer here is carbon monoxide. This has the highest affinity with the blood in our body, with hemoglobin in our body. Obviously, we all like that the friend circle, in our friend circle, who is the coolest and the worst friend is, he appears to be the most coolest one. So CO2 has the worst with your blood. So that is why this is the worst one has more affinity. Okay, then CO2, and the least one is your oxygen. So like that you can remember. That is why it is known as the silent killer. Carbon monoxide is known as the silent killer because it is colorless, odorless, and yet it can create serious effect on the heart and brain. Next, sour milk contains, if the milk has become sour, that means it will contain which acid? The hint is the lactose sugar, okay, which is found in milk. So with that you can answer. Yes, I remember that. Lactic acid, yes, the correct answer is lactic acid. Okay, let us see what about the other acids. For vinegar, it is, the acid is known as acidic acid. Okay, for the orange juice and all the citric fruits, they contain the citric acid. For tamarind or imli, there is the tartaric acid. For tomato, oxalic acid, this has also been repeatedly asked. For sour milk or curd, lactic acid. For lemon, again it is citrus in nature, so it will have the citric acid. For ant sting, this has been repeatedly asked, it has the methanoic acid. For the nettle sting also, it has the methanoic acid. Coming to the next question, the acid, this is question number 5 because 2 slides initially I had added. So the slide number is here. Okay, I have kept it in this side now, so that's why it's difficult. Next time I'll keep it here, so it will be easy. The acid used in lead storage cell is, which acid is used? Phosphoric acid, hydrochloric acid, nitric acid, or sulfuric acid. So this is also repeated, correct? That is your sulfuric acid. So sulfuric acid is used. However, a few more things which can be asked regarding this. For sulfuric acid, lead acid battery. This we have to remember, lead acid battery. For phosphoric acid, is anything possible with this one? It is the key component in the synthesis of certain lithium ion battery cathodes. For lead acid batteries, we know it is sulfuric acid, and for lithium ion battery, the cathodes are made of some, your phosphoric acid is there in it. Okay, so these two we have to remember. Then for hydrochloric acid, nothing is there because chlorine already is there, so it will be highly corrosive, so nothing can be there. For nitric acid also, it is very strong, so that is why also it cannot be used. Next, coming to the alum. We all know what is alum. Alum is basically fitkiri, which is used for your sometimes for cleaning the water in the well as well, it is added. However, it has many other functions also. It is used, it should be there kept in every household. If there is bleeding in the gum, then also alum can be for teeth ache. It is very painful if the teeth will ache, but little bit of alum can also help at times. So alum stops bleeding in minor cuts because of, why? Because of solvation, emulsion, dialysis or coagulation. Bleeding stop itself means, forget about alum, it will mean coagulation. Yes. So even if you are not sure about the answer, bleeding, the clotting of the bleeding itself means blood coagulation. So the answer will be blood coagulation or coagulation. Now this will stop because of what? Because of the coagulation. Because it is positively charged aluminium ions are there. Now we have to remember that it is used for various other purpose also. It stops the bleeding. So in many other cases it can be used. Plaster of Paris is made of partial dehydration of which of the following? Plaster of Paris, if anything goes wrong, say somebody got a major injury and then plaster might be required in case of fractures. So what is used? What is the raw material? What is it primarily made of? Dehydration, partial dehydration happens and then 1.5 molecule of water is separated and half is, so of what? The primary material is your gypsum. Correct. The correct answer is gypsum. Okay, here one thing might be remember here, that in this case sometimes they ask the formula also, CSO4 dot half H2O. This is how plaster of Paris is made, and then 1 by half H2O. This water molecule is separated. That is what the partial dehydration has happened for the gypsum salt. Coming to water can be separated from alcohol water mixture by, okay, if there is say oil and water, if there is say sand and water, then it is very easy. Okay, the sand will fall down and then by decantation the water can be separated and the sand will fall down. But here it is mixing, then oil and water again it does not mix, so one will fall, the water will say fall down and oil will float and it will stay like that. What to do in case of both are miscible? Decantation, evaporation, distillation or sublimation. What to do? Distillation. Yes, we can do distillation in this particular case. So what will happen is, if we will mix it, it is anyhow mixable, so it is mixed properly, and then the evaporation of alcohol will happen faster, then it will be brought out of some tube, and partial distillation, or you can say it will be removed, because the temperature at which it will give the vapors, it is different. So this will start settling here and then it will be pulled out. What remains is water. Okay, so distillation is the most effective method because alcohol will vaporize at a lower temperature. It will go out and what will be left is the water. Decantation, if two non, for example, I told you sand plus water, this will never mix with one another. So in that case, the sand will fall down and the water can be separated simply by pouring it into another jar. This is known as what? This is known as decantation. Evaporation can be done, but it is what will happen after the vapors, similar to evaporation but not exactly evaporation. In this one, in evaporation will completely go out, but in case of distillation, it is the vapors are out but not outside the setup. It is then taken out, pulled out. Sublimation, it is done when, say for example, naphthalene balls, okay, when we place it in our cupboards, it will go directly from solid state to gas state. There is no liquid state of naphthalene ball, directly from solid to gas. But in case of ice, what happens? It goes from, first it will melt, it will become water, then we'll heat the water, it will become vapor or water vapor, or then it will become gas. Okay, if it goes directly from solid to gas, it is known as sublimation in that case. Camphor, for example, that is also another example. Milk sugar is very simple question. What is it? Lactose, maltose, galactose or sucrose? S for sucrose, S for sugarcane. Okay. So milk has. Sublimation of camphor is also there. Yes, it is your lactose. Milk sugar has lactose. Lactose is there in the milk sugar, or say in any of the, most of the milk and dairy products. Maltose is there in case of malt, single malt. In case of malt beverages, it is nothing but pure form of glucose. If anybody has, say, diabetes problem, sugar problem and alcohol on top of that, then the things degrade very fast, faster than a person who does not have sugar. It will degrade very fast. So these are pure form of poisons. Sugar from the starchy grains, so that is there in maltose. Galactose, simple sugar. Okay, primarily milk sugar is your lactose and galactose is your other simple sugars. S for sucrose, S for sugarcane. So if we know that sugarcane has the sucrose, that means beet is also used to make sugar. So beet will also have the sucrose. So common table salt also has the sucrose, and that is also made from sugarcane only in case of India. Then the brown colored sugar, some are made from beet as well. That is why if a person will eat the beetroot as it is with some, say, salad, that time the sugar will not spike. But if a person will eat beet juice on a daily basis, if has sugar, the sugar will spike. Normally we think it's healthy, okay, drink. No, it will spike because sugar only, no. Fiber is missing when we have made it into juice. That is the problem. Petroleum is a mixture of, in the chapter, in which chapter we study petroleum, that is what it is the mixture of. Yes, we study in the chapter hydrocarbons, right? In carbon and its compounds only, we study the hydrocarbons, and there we study chemistry in everyday life, and there we study fuel, petrol, etc. So it is, the name of the chapter itself is giving the answer, hydrocarbons. The gas used for filling weather balloons is which of the following gas is used? Recently, I was scrolling and I found a video where a newly married couple was holding the balloons like this. They came outside for the photographs or something like that, and it burst and there was fire in the incident. So dangerous. If used like that. So what is there? It is helium. Correct answer is helium is used for filling the weather balloons. Why? Because helium is lighter. Hydrogen, helium, it is lighter, and that is why also everybody wanted to, even hydrogen also want to get the helium structure, because noble, everybody wants to become stable by getting the nearest noble gas configuration. So that is why this one will also try, but since it is noble, so that is why generally it is non-inflammable, but it is used in small occasions, like if it has to be used in say at a cost effective basis, then there are many additions to it, as a result of which this thing can happen. So hydrogen is the lightest gas. However, if we see, then this one is used for the balloons and it will go up. Okay. Earlier hydrogen was also used, but the problem is the stability. Hydrogen is not found in atmosphere because, why it is not found? Hydrogen is not found in atmosphere because just now we have seen that it is the lightest gas. So if something is lightest, that means it will go up very easily and it will say bye, it will go outside. Similarly, ozone is also very light. So as a result of which ozone will also say bye and it will go straight to the stratosphere. And that is why it can make holes in the atmosphere. Right? So these things can happen. What is the answer now? Because it's highly inflammable, but atmosphere does not works like that. Lightest gas, it is absorbed by plants or it immediately combines with oxygen to form water. Which one is the correct one? It is the lightest gas. Yes, 2 is the correct answer. It is the lightest gas. Hydrogen is not found in atmosphere because it is the lightest gas. So it will go up in the atmosphere. Okay. That is why in the Earth's atmosphere only traces are found. The rest, it's said bye-bye. Now coming to who discovered the atom bomb. You have seen that movie, no? I have seen it in the hall. So that image and that video of when the experiment happened, Oppenheimer. Who discovered the atom bomb? Madame Curie, Marie Curie, Otto Hahn or Albert Einstein. Though there were many personalities behind this, but one we have to select. Yes, that is your Otto Hahn. Though there were many people, but we have to remember Otto Hahn, Fritz Strassmann, and explained by Liz Mentor. Mainly we have to remember Otto Hahn because he got the Nobel Prize in chemistry. That is why we have to remember him. Then the name of the movie was Oppenheimer because it was led by Oppenheimer. Otherwise they could have kept other names also maybe. Now what happens here is nuclear fission. Please remember this. It has been asked many times. It is nuclear fission. Say 1 will be 2, 2 will be 4 like this. And when we say fusion, that happens in case of the sun. What happens? Fusion. Okay. So 4 will come 2, then 2, 1 like that. That is fusion. Fusion reaction and fission reaction. Which one of the following organic compounds has fruity smell? The first class of chemistry was available, carbon and its compound. There also we had started. It is on YouTube as well. Now alcohol, aldehyde, ester or ether. Whenever there is the fruity smell, it is associated with what? This one, write down ester or 3. Yes, so it is your ester that is associated with the fruity smell. They are also used in, say, even deodorants also they can be used. For the aromas, they can be used. For example, fruity smells like, say, if isoamyl acetate, that will smell like the banana flavor. Methyl butanoate, that will smell like the apple flavor. So these flavoring of food can be used. You know, even in the biryanis also, they are using actual kesar or kesar flavor. Most of the times what we get is flavor, vanilla, kesar, the costly items. But the flavoring agents will come for just 15 to 20 rupees for the entire bottle, and drops of the essence are enough. What material is used to make electric heater coil? Very simple. Copper is ideally the best one for the electric wires, and copper wires, copper coil, all these are used in AC, etc. No, we hear about them. So iron, not option is only not there. Silver could have been used. Nichrome. So what is the correct answer? What is used for making the heater coil? Even if it breaks, it is very easy to replace another one, that is nichrome. Okay, nichrome is used. Nichrome is alloy. Alloy composed of what? Nichrome is for nickel, and here chrome is for chromium. So that is what we call as nichrome. So since it is alloy, that means it can be made as per our requirements. So it has high melting point and high electric resistance. Also resistance to oxidation at high temperature. That is why this can be used. Coming to byproduct obtained by soap industry. We had already studied that there is soaponification happening. That is the process. What is the byproduct? This is also there in the first class itself, which is here in the English channel itself. It is there in that class. Caustic soda, glycerol, naphthalene out of the option, or caustic potash. What is the correct answer? Glycerol, yes. So see, I think 3-4 questions can be seen directly from the first, though this is the mixed series, but still. Okay, so glycerol, also known as glycerin, is produced during the saponification process, where fats and oils react with the strong alkali. Soaps are basically alkaline in nature, right? So it can be caustic soda, it can be caustic potash, this anything alkali, whatever they want to add, they can add, and the soda component is also there. So much so that normal soda also can be probably used for some skincare purposes. Anyways, polythene is a polymer of what? Ethylene, propylene, acetylene, or aniline. Now, though all of them are not required here, but since polythene we all know is non-biodegradable, causing so much harm to the environment, so that is why this question becomes common. Okay, so what will be the answer? It is a polymer of it is a polymer of ethylene. It is a polymer of what? It is a polymer of ethylene. The ethylene monomers, they link together in the polymerization reaction to form long polymer chain of polythene. We know that carbon can form the long chains, right? So similarly here also, ethylene means methane, ethane, then ethylene. So it is ethylene polymer will be there. Okay, I told you it will form the double bond, right? Then if it would have been say ethane, then there would have been the single bond, right? In this case there will be tetravalency, so 1 2 3 1 2 3, 6 carbon can come, C2H6. Here 2 already done, that means 3 4 3 4, 1 2 3 4, so it is C2H4. The ethylene monomers anyways in the long chain reactions can be formed, and just for polythene we have to remember. For determination of age of which of the following carbon dating method is used? If we have to determine the age, then we know that carbon dating is used. But it is used for whom? For fossils we use. for rocks, for trees, or for 1 and 2, that is for fossils and rocks. Carbon dating 5,000 years back, 7,000 years back, how do we find out how many years back? For trees, we cannot do that. Fossils, dinosaur fossils, or even in a leaves also, even in the mud also, if some fossil is trapped, we can find out. In the rocks also, if some things are trapped, we can find out. What will be the answer? It will be both fossils and rocks. Even if we don't find fossil sometimes, in that case, rocks also can be used. So both can be used, okay? Fossils and rocks. Trees won't survive that much, that's why. So for fossil, carbon dating is widely used to determine the age of any fossil. If we find a dinosaur, we can find out, okay, that how old it is. If it is very old, then say the amount of carbon, etc., the amount of the organic substance will probably be less. So like that. Then in case of rocks, also radiocarbon dating is, it can be used. So for both, this can be used. Coming to a substance which readily forms colloidal solution in contact with water is called. So what is the substance that will form colloids when it is mixed with water? It is extrinsic colloid, associated colloid, hydrophobic colloid, or hydrophilic colloid. Philic means loving something. Hydro means water. So if it is water loving, that means it is hydrophilic. If it fears water, phobia. Phobia is when somebody is fearing something. So if it is phobic, that means it is fearing. Okay, it will not combine. So that is, now they are asking colloid solution is formed. That means what will be the answer? Philic means it will mix properly, no? Hydrophilic means it will mix properly. So a hydrophilic colloid, also known as lyophilic colloid or intrinsic colloid, happens when the dispersion will happen in the medium. Okay, some examples are starch, gelatin, gum arabic, or take this example, cut potato. Cut potato, put it in the water for say 1 hour or 2 hours. After that, remove the potato, whatever you will find in the water. If it will be kept out or some water will be removed, then what we will find is this substance, a comparatively hard substance though, but other elements or other say fruits and vegetables, we can get other substances like gelatin, etc. When formaldehyde and potassium hydroxide are heated, when formaldehyde and potassium hydroxide are heated, we get, this also was in the last class itself, if there is one aldehyde component and if there is potassium hydroxide, we get what? Acetylene, methyl alcohol, methane, or ethyl formate. What do we get? Methyl alcohol. So let us have a look at this. Let us have a look at this equation. If formaldehyde and potassium hydroxide, if it is heated, then what do we get? We get methyl alcohol. Now see, methane, ethane, propane, butane. So methane has one carbon only. So it has to again fulfill the tetravalency. So one hydrogen will be there and 3 OH or the alcohol OH will be there and potassium formate. So we get the methyl alcohol and potassium formate. Okay. So here we have to just remember that formaldehyde means we just have to see that one carbon and one carbon. This we have to see here. It can be different also at times. However, it works most of the time. When concentrated H2SO4 is added to dry potassium nitrate, brown fumes are evolved. These fumes are due to, these fumes will be because of which one? Now, even if we don't know the answer, we can see that it cannot be a sulfur dioxide or oxides of sulfur components, because they're talking about the brown fumes. So these two cannot be our answer. Now, out of this, NO2 or N2O? Right? Okay, so the correct answer here will be NO2. Okay, because how often do you see this? Okay, oxides of sulfur and nitrogen, so it will be, okay. So even if you are not sure about the answer, you can answer like this, and if you have practiced each of them, then it is well and good. So brown fumes evolve when concentrated H2SO4 is added to the dry potassium nitrate. Due to nitrogen dioxide, NO2 will be formed. The polymer used in making plastic crockery is, plastic crockery can be broken, or the top layer is, if it is complete plastic, then it will be melted. Now there are two things. Same, say, what do you call this? Same crockery, it will appear similar, but sometimes the price is really very less and sometimes the price is more. Yes or no? If the top layer is of plastic, it is very less, design is same. It can be melamine, or you can say China clay, we used to call at one time. Then it can be glass, the Borosil plates which we get, that will be in the costlier end. But if you will go to a mall, you want to buy the crockery, same plate, same flower designs, sometimes you will see this is available for 71 plate, sometimes you will see it is available for 201 plate, because this is different and this is different. The borosilicate ones, the Borosil ones, you can put it in the microwave in any temperature, it will still last. Okay, so that is why the price is different. Plastic, melamine, and the glass borosilicates. Next question, vulcanization of rubber is carried out by adding which of the following? If the word vulcanization itself is used, that means it will be what? Sulfur, carbon, ozone, or phosphorus. If the term vulcanization is used, yes, then it will be sulfur. So 1 is the correct answer. If the term is used, that means it will be sulfur. Which of the following is used in dating archaeological findings? Just now we have seen before some time carbon dating. Okay. So what will it be? It will be, what will be the answer? Carbon dating. Uranium, hydrogen, oxygen, carbon. Yes. So 2 will be the answer, that is carbon dating. Preparation of dalda or banaspati ghee. The same ghee packets, sometimes even for the same price also, look at the confidence, they're selling for the same price also sometimes. Some brands, otherwise dalda is very less price and the ghee is more price, but some brands, they are selling this vegetable ghee. It is written there vanaspati ghee, it is written vegetable ghee at the same price, not the cow milk ghee. That one is made from the vegetable oil, so price should be less, no, than the milk ghee. So next time if you are buying from the, especially in local products, these are very much available in, this is the most common brand in Assam and Bengal. So whenever you are buying, always check what it is there, especially for local. Otherwise the brand products, they are selling the normal ghee only. So what is used here? Hydrolysis, hydrogenation, oxidation, or ozonolysis. Yes, just like it is called saponification, here it is called as hydrogenation. Smoke is formed due to. Why is smoke formed? Say only if a car is releasing, say, gases, only gas should be there. Why some smoke elements will be seen? Why some ash is there flying? So all these are what? Nothing but solid dispersed in gas. This ash is, say, solid, and then it is dispersed in the gas, the atmosphere. Solid dispersed in liquid, gas dispersed in solid, or gas dispersed in gas. What is it? It is for this one. Gas dispersed in gas. No, ash is solid, no? If ash particles will be there, then that is solid, no? If we burn a paper, then some gas will be there, and for the paper itself, some small pieces we can see, no? That is the solid pieces which is there in the gas, in the air. Okay, so that is why it is solid which is dispersed in gas. Okay, no problem in that. So smoke is formed by solid dispersed in gas. They can be like the carbon, ash, etc., and which is suspended in the gas or in the air. So it is a type of aerosol. Aerosol means air plus it is in the solid, so we can remember aerosol. It is a type of colloid. When we study type of colloids, there also we study this type of colloids. Which of the following chemicals is used in photography? In photography, we use which of the following chemicals? Aluminium hydroxide, silver bromide, potassium nitrate, or sodium chloride? Yes, we use silver bromide for photography. This is also a common question, silver bromide. Now for the others, for the aluminium hydroxide, what is the primary use? We used as antacid, and we used for water purification. Then for potassium nitrate, as the name itself is very clear, it will be used for fireworks and fertilizers. Fireworks and fertilizers. Then sodium chloride is nothing but NaCl. It is the common table salt which we are consuming on everyday basis. Okay. Next question, what is the primary or the principal ore of aluminium? This is from the topic metal and their ores. This is from that topic. Dolomite, copper, lignite, or bauxite? It's very simple. It is your bauxite. Correct. Which gas is used as fire extinguisher? This is also very simple. The fire extinguishers will be kept like this, no? Hanging in the wall. So which is used? Carbon dioxide. Carbon monoxide, people will not die with the fire, but they will die with the carbon monoxide gas itself. Carbon suboxide or sulfur dioxide? The answer here is, which gas is used? CO2, that is carbon dioxide gas, is used in the fire extinguisher. And if say nothing is available and a person, or say in small little place, if anybody has to be safe, then a blanket is covered immediately. This is used for, say, stopping the oxygen supply. For anything, if instant the fire has to be stopped or controlled, instant, but it should not be that the blanket is also burning with that. Okay, or if the person itself rolls, then probably it can help to some extent, probably. Which one of the following is extensively used for sterilizing water? For water sterilization, for water, say in a well, I told you what is used. Bleaching powder is used, alum is used, borax is used, or soda powder is used. In the initial part itself, bleaching powder, why? We cannot consume, no? What about alum, fitkiri? This also can be used, no? Yeah. So we can use the alum for water purification. Okay. which one? Bleaching powder is used in case of drains, because that water nobody needs for any purpose, no? So there it can be used. Or for cloth, for cleaning of the cloth, it can be used. Which one of the following acids is used in battery? What is used in battery? This also we already know. HCl is used, or hydrofluoric acid is used, or sulfuric acid is used, or sulfurous acid is used. Yes, very simple. Sulfuric acid can be used in the batteries. The major constituent of air is, we have seen hydrogen, no, it will just go out, say bye bye, and it will light us, so it can fly. Then nitrogen, carbon dioxide, oxygen, or hydrogen. This is not. 78% of the atmosphere is nothing but nitrogen. So the answer here will be nitrogen. Carbon dioxide is 0.03%. So with this, I think we are going to end our today's Wednesday live chemistry class at 1 p.m. Then in the weekend, you can join the biology sessions, okay, which we have started. Like biology classes were going, but next class will be for magnets, because same science book, no, for class 6, same book is there. For physics, chemistry, well, nothing less. 6 means after 5 they have just started. But you know, in the last class, which is already there in the channel, you can go and check how nicely they have given the relationship between the monocotyledons and dicotyledons, their leaves, parallel venation, or your reticulate venation, and then the root, whether tap root or the fibrous root. That relationship is given in class 6, so that you know nobody forgets again. So we will continue this in the weekend series, and I think for biology life you can join on Tuesday every day. Okay, so with this I am ending this session. You can please consider subscribing to the channel and sharing this video. Okay, take care, stay blessed, bye bye.